Hello everyone, myself Priyanka, and today we are going to talk about solution for malware detection for cloud volume ONTAP technology. As we know that NetApp is very leading technology partner in storage domain, and they have launched cloud volume ONTAP for different cloud service providers such as AWS, Azure, and Google Cloud. So here we are going to discuss now. Cloud Volume ONTAP is compatible with AWS, and inside that, when we are sharing particular SMB share, and we have number of files embedded in that share, so how we can detect those files are malicious or not using machine learning algorithm. So let's take a glimpse of this project. So here we have proposed this research question, like how can AI and machine learning can be effectively integrated into cloud volume ONTAP to enhance malware detection capabilities. As we know that cloud volume is part of AWS or Azure or Google Cloud. It can be part of any CSP. So there are high chances if it is shared as SMB share and users are copying different number of files with different type, then it's high responsibility of system administrator how to run particularly scans on those directories. So this particular malware detection using artificial intelligence will help system admin to scan those folder on priority which has malicious files inside it. So this is the motivation behind designing this problem statement solution. So this is basic architecture diagram for proposed system. Here we have on-premise NetApp storage with SMB share. Let's say we are backing up on cloud under VPC. Here is we can see here production site zone and here disaster recovery backup availability zone. So here also we are applying this malware protection, and on disaster recovery site also we are having this malware protection. So that way we are securing and we are making sure that we are targeting basically SMB share Windows files copied on cloud volume ONTAP, and there are very less or zero number of malicious file on actual production and DR side. So we have done some literature review about this project. So prior art we have learned technologies using machine learning. Earlier there was no direct research related to cloud volume ONTAP. So we have here what we have tried, like we have tried to integrate different modules and already done work, and we have consolidated and come up with the novel solution. So here we can see prior art related to malware detection using machine learning. Then we have read one paper related to behavioral and data management analysis of the files. Then we have done some research about file metadata so that we can classify files and mark it as malicious depending on the metadata information as well. Then we have deep dive into SMB share, how it's actually practically used and what's the scope of that, and how we are having client interactions with this shared SMB folders. Okay, then again we have done some research related to network traffic in the cloud premises and how malware is behaving in that. So after doing a ample amount of literature review, we have come up with the AI driven behavioral analysis. Then we have decided to complete this project development into three parts basically, that we will discuss in further part. So here we have analyzed for suitable algorithms for this project. Then we have done this particular project planning, like how we are going to complete this project. So starting from the beginning, we have selected project domain, then we have done literature review about this selected topic, then we have learned the technology Python, artificial intelligence and machine learning related modules. Then we have started deploying, then we have started building model, then deployment of that model, then we have tested model, and then one more task we have done, that is creating the client to have the API for this. And then we have drafted the report along with conclusion. So as part of implementation, here we can see first and foremost a very important stage is building model, and inside that we have used subtask. This Ember, you can see this ANK malware benchmark for research. This is basically a huge library where we have millions of malware data sample, and that data is again synced up with virus total database, and we have signature based malwares details available. So we are using that library. As we have number of samples, so those samples who are having null values, we are simply discarding those rows to improve the performance of model. And then we are after data filtration, we are actually training that model with one epoch, and then after training we are doing some testing for that model. So these are the glimpse of our project code part. So let's take a look at library in detail in Jupyter Notebook. Here we can see task 1, building model building. So in that task we have to first train the model, then as part of that we have done this dataset extraction, and after that we have selected number of rows which are actually relevant to train the model, and this is the output. And we have applied data pre-processing. After pre-processing, main part of this modeled architecture and training, in that we have used this TensorFlow and sequential data processing, so to improve particular binary files processing. And once we have selected epoch of 256 batch size, we have this output after training the model in one go. Then we have tested this model with Ember. It's more relevant and giving data accurately. With Anaconda PE file, this particular file is detected as a malware file. So using this Ember repository, prediction was more accurate. So next task we have done is model deployment. So in that we have used AWS CSP, and we have created platform to load that model. So here is a JSON, my model.json file, and we have created a plugin to interact with the model with the cloud platform. And then our endpoint creation with using AWS SageMaker is successful. Okay, after create deploying model into cloud, third task we have done is client execution. So malware detection API here we have created. So after executing this client p.py, we actually got this particular PI result. And as we can see, this file is malware specific file. So here we got the correct output as expected. So he, this is particular this is Git based repository. Here you can check all the details under my ID, and there are readme file as well and project instructions as well. Okay, and now let's take a look at further part of the report. So after implementation we have the conclusion of this project, that building this project we have gained immense knowledge about the artificial intelligence and machine learning. As we in the beginning we were aware about the storage domain, and we want to leverage this knowledge further into cyber security. So we thought of to secure storage domain and how we can improve the security aspect of it, and we have successfully completed this with the insightful solutions, such as we can protect SMB shares of cloud volume ONTAP, and this has industry standard potential and directly can be implemented as one of the feature in leading storage partner technology. So yes, this research was worth, and we got immense opportunity to deep dive more. Thank you NCI and program director for designing such a valuable assignment for us, which allowed us to deep dive into malware and artificial intelligence and with cybersecurity perspective. Thank you for Professor Jamal for guiding us on time, and that led to a quality project. Thank you everyone for listening. Do reach out if you feel like, if you have any query further. Thank you so much.